All right, let's pick up where we left off. We're going to use our TI calculator to compare the following graphs so we can make a conclusion on, roughly speaking, what exponential functions graphs look like. So let's go open up our TI. And for part A of this example, we're going to put 2 to the x, which we already did by hand upstairs, 3 to the x, and 4 to the x to see what happens as the base gets bigger and bigger. So we've got 2 to the x, 3 to the x, and 4 to the x. So we're going to do a zoom 6, and there's 2 to the x, there's 3 to the x, and there's 4 to the x. So if you notice, 4 to the x with the bigger base is kind of taller because the y values are increasing quicker as I look to the right of the origin, or the x value 0. So it makes sense that bigger bases rise quicker than smaller bases. 2 is in blue, 3 to the x is in red, and 4 to the x is in black. Let's just zoom in, sort of like near the origin, to see what happens on this left side when the x values are negative. So if I zoom in, notice what happens is the blue graph, 2 to the x, which was not as high on the right side as the highest one on the left. 3 to the x is in the middle, and then 4 to the x was higher in height compared to the other guys on the right, but on the left, when the exponents are negative, it ends up becoming lower and smaller, and that makes sense when we looked at the XY chart when we did the examples by hand. So ultimately on the right, when x is bigger than 0, the bigger the base, the higher the graph is. And on the left, the bigger the base, the lower the graph is, because you have a big base raised to a negative exponent. Now let's go look at the next one. Let's keep track of this in the notes, and then we'll go look at part B. So quickly, what we mentioned verbally, notice if I look at 2 to the x, -1 gives me a flipped reciprocal, a half of 0.5 on the left. So the blue one is like 0.5, and 1 on the right gives me 2 up here. Versus if I look at a bigger base, 4 to the -1 gives me something even smaller. That's why the black function 4 to the x is lower than 2 to the x on the left. However, on the right, when x is positive, I get 4 to the 1, which ends up being bigger, and 4 to the 1 will eventually have a point up here when the input is 1. So the bigger the base, the quicker it rises on the right, and on the left, it's actually lower than a smaller base. Now let's go look at bases that are less than 1 and see what they behave like. So we're going to put a half x, a third x, and a fourth x on our TI. And we're going to do a zoom 6. And notice like the half x that I did by hand, you're going down as you're walking to the right because it's a decay. And also the 4, the 1/4 to the x, the blue, is the higher one versus the half to the x, which happens to be lower, again because of the negative exponents. If I do a zoom in to see what happens when the values of x are positive versus negative, remember 2 to the x, or half to the x, is this blue one, a third to the x is the red one, and 1/4 to the x is the black one. On the right, a half to the x happens to be higher, and a fourth to the x happens to be lower. So let's go make a note of that in our graph. So we got a half to the x, a third to the x, and 1/4 to the x. And we see that it kind of behaves like the previous ones where the bases were bigger than 1, but sort of flipped, which kind of makes sense if you think about it. Let's say I take this and think of it as 4 to the -1 raised to the x, and then do power next multiplied by the other power. That's going to be 4 to the -x is all I'm looking at, which means all I did was I took 4 to the x and reflected it about the y-axis, because I made the x's the opposite of what they were. So basically 1/4 to the x in black here is really a reflection of 4 to the x in black up there. That's all we've done. We've taken the three functions and reflected them about the y-axis. But generally for us, what a bigger base bigger than 1 versus a base smaller than 1 means, so we'll just have these general two shapes to keep in mind. I either have a growth, if I'm thinking of, let's say y equals c b to the x. If the c is whatever it is, that'll be my starting point. And all of the ones we did up here, the c was 1. That's why they all went through 0, 1. So we'll say it's either a growth that looks like that for b bigger than 1, or we'll have a decay when b is less than 1. So those are the general shapes I want you to keep in mind for exponential functions. As you're walking to the right, you either go up or go down, depending on whether it's a growth or a decay. And remember, keep in mind, they both have that horizontal asymptote of y equals 0, unless you've happened to shift things around. And shifting things around comes from transformations. So let's look at example 4 and just do a sketch. We're not going to use our TI necessarily. We're just going to use transformation ideas from before to do a sketch and give the domain and the range of this guy. So we know what 2 to the x looks like. All this guy did was take 2 to the x and shifted 1 up, right? So 2 to the x has a base bigger than 1. Initially looked like that when we did it by hand. And if I shifted up 1, that y-intercept of 0, 1 is going to go to 0, 2 and look like that. And I also have to keep in mind that that number is going to become my horizontal asymptote, because my horizontal asymptote used to be at 0, but now it got pushed 1 up. So a rough sketch of 2 to the x plus 1 is just going to be the graph we've drawn here. The domain and the range, no big deal, right? The domain for exponential functions is always negative infinity to positive infinity, because I'm going all the way to the left and all the way to the right. The range, however, for this graph starts from the bottom where the horizontal asymptote starts at 1, and remember, it doesn't touch the horizontal asymptote, so I'm leaving it open with parentheses, and then I'm going all the way up and up and up forever to infinity. And again, we can look at that on our TI too. It'll give us an idea of what it looks like, but we don't need to. We know that the base is bigger than 1, so I'm going up as I go to the right by using the first basic graph from up here, and then I just shifted all of that 1 up unit. Let's have you guys pause the video and try this guy and tell me what shifts, reflections, or anything else is going on. So hopefully you had a chance to try this on your own. Remember, a negative outside of 3 to the x means it's reflected about the x-axis, means all the y values become the opposite of what they were. Now, please don't confuse that with, let's scroll up quickly. Up here, when we were talking about exponential functions, remember I said that b is always bigger than 0, meaning the base is always positive. So this base, b, is positive, and then I could have a positive or a negative number in front of it that could potentially reflect it. That's what's going on in this problem. So I'm not making the base negative. I don't have parentheses around my base with an exponent. In this problem, the base is 3, so I'm looking at 3 to the x, and the negative simply reflects it about the x-axis. And then this negative 2 on the outside shifts the 3 to the x function down 2. So basically I had 3 to the x, then it got reflected, then it got shifted down. So if I do a quick sketch of that, 3 to the x again is a growth, so it started off going through 1, 0, 1 like this, like my basic function. And then it got reflected about the x-axis, so I'll bring it down like that. So I'll say 1 was my original, 2 is my reflection, And then from there, it also went down 2 units. So from here, it went 1, 2 units further down. So I'll say that's my final graph. And I shouldn't forget that this guy at the end is going to be my horizontal asymptote. So my horizontal asymptote became y equals -2 because everything shifted down 2 units. And again, you can look at your TI for a quick sketch. Let's go clean these guys and put -3 to the x -2, and we're going to do a zoom 6 for a standard window. And there we go. It looks something like roughly what we got there.